mth102. Let's see, is it showing well? If it's showing well, let's see with reaction. Okay. Okay then. All right, it's time. It's time. So if you have anything to say, those are raising your arms, you can say it now. Mr. David, can you please drop your hand? You are raising it. All right. So I think we have to kick off right now. I'm starting from the beginning of the module, from the beginning of the material, the course material. We're starting from the first module, and I wish everyone the best. It's not gonna be a hard stop on us, not really hard at all. So we have quiet time, some time to do what's on it. Okay, Math 102, as we all know, is full of functions, limits, and calculus. Let's say calculus. So, but before we can understand calculus, we have to understand some certain things. That's functions. Because everything we are doing in calculus differentiates this, integrates this. Everything we are differentiating will be a function. Everything we are integrating will also be a function. That's why we have to understand what function is first. So then, what are the limitations to this function? What are the certain things that could go on with this function? That's why we have to study limits too. So because of that, we'll be taking functions and limits first. Functions and limits will be our first topic. Even though function and limits couldn't be finished today, but at least we'll do a lot on function today. We'll take function very well today. I wish us the best. So when we mention function, everyone, are we together? Shall I start my explanation now? Just let's see with a reaction. Okay. When we talk about function, guys, function simply entails three things. What are the three things? I, P, O. That is function. Function goes on with computer several. When we mention function, it entails three things. I, P, O. And that's what? Input, processing. I would like you to be putting this down. They are important. There are certain guidelines for you to remember the facts. Input, processing, and output. You are going to understand the trick now. Function means input, processing, and output. Now look at my processor here. I'm going to input a value. I'm going to input a value into the processor, and the processor is going to make the value to undergo some functions. To undergo some function, and after undergoing this function, it will show something on the monitor for us. That is the output. It's going to output a particular value. So now, let's say I have 5 here. Let's say I have 5 here, and the function is sine. And the function is sine, or let's take it fine. I have 60 here as my input. I input 60. And a function designed there before is sine. By the time I input 60 into the function box, what is going to be the output? That is sine 60. That's going to give me 0.8660. So sine is the function. Sine is the function, this is the input, and the output is right here. Okay, I'm not using sine as the function anymore. I'm using inverse. Inverse. Inverse means reciprocal. Look at this. Inverse. That is the function. That is the processor. The way the processor is designed. So I'm imputing 5 into this inverse function. That means the inverse function of 5. That means if it was sine that is here, it will be the sine of 5. If it was square that is here, the square of the 5 that I'm imputing. So now the inverse is here and 5 is here. We are imputing 5 into the processor. So definitely the output should be the value of the inverse of 5, and that is 1 over 5, that's 0.2. Okay, now I'm taking 45 and I'm saying the function is cos. I would like you to be putting these things down. Basic things to understand in functions. Once you understand stuff like this, it will be very easy for you to do. Forty-five is the input and cos is here, the output. Since the processor is here, the output will be cos 45. That's going to be root 2 over root 2. That's 0.7071. So, and it goes that way. If this thing wasn't cos anymore, if it's changed to tan, that is, the function becomes tan, definitely my answer is going to be, that means the output of the function is going to be tan 45. And I think that's apparently 1. Exactly 1. So with this now, we can derive that if x is the input and a particular function is here, sine, therefore the output will be sine x, which is equal to y. I can call y the function of x. I can say y is a function of x. That is where we are driving to or at. Y equals sine x. Therefore, y is a quantity that is depending on x. Therefore, y is a function of x. Y is a function of x. If I said y equals x squared, it also means y is a function of x. What is that function? Square function of x. If I said y equals f of x, that means y is an f function of x. What is f? I don't know. It might be any function. Let's say it is inverse function of x. It might be tan function of x. It might be sine function of x. Are we getting it first? Are we understanding what a function means? It's a person. Okay. It's just a person I'm saying. All right. All these are just to explain what function implies. So let me hold it right here. So now let's talk about the next thing. I don't know if you put it down. I would like you to have them down. So this is what function is. The next thing to take is evaluation of functions. Evaluation of functions. This is a function, f of x. This function, f of x equals x squared plus 3x minus 7. Are we together? This function, f of x, means x squared plus 3x minus 7. Now, evaluation means what is f of 1? What I'm doing. Note what I'm doing very well, please. What is f of 1? F of x means x squared plus 3x minus 7. Listen very well. F of x means x squared plus 3x minus 7. Definitely, f of 1 should be 1 squared plus 3y minus 7. As simple as that. I suppose you should get me very well. F of x means x squared plus 3x minus 7. So f of 1 means 1 squared plus 3 times 1 minus 7. Apparently, I have 1 minus 3 minus 7. So f of 1 gives me minus 9. That is the evaluation. That is, if it was 1 that underwent this problem, this function, this is a function. If it was 1 that we impute into that computer that gave us something that is this, it's exactly minus 9 that the computer will give us as the output. If it's 1 like we impute instead of imputing x. So this function now, x squared plus 3x minus 7. If we change x to 1, that means f of 1 instead of f of x.
Sorry. I think you made a mistake. Just
Okay, is it 1 plus 3 minus
yes,
7? Okay, okay,
yes,
okay.
yes, yes.
Okay, no, sorry. Sorry for that. That's minus 3. Thank you. Thank you very much. So 1 plus 3 minus 7, that's minus 3. I mean, 4 minus 7, that's minus 3. So that is that as for that. One more example on evaluation. Then we confirm if this is a function of this is a function of this, stuff like that. Let's say f of minus 4. F of minus 4. We are given the function to be x cubed minus 2x plus 2. This is the function x cubed minus 2x plus 2. What is f of minus 4? So f of minus 4 would be equal to minus 4 cubed minus 2 times minus 4 plus this 2 here. I'm having minus 64 plus 8 plus 2. That's minus 54. So f of minus 4 equals minus 54. And that's how it goes. So any question from anyone now on this? Any question? So since there is no question, let's all solve this. F of x equals x cubed minus 2x squared plus 5x. X cubed minus 2x squared. F of x equals x cubed minus 2x squared plus 5x. X cubed minus 2x squared plus 5x. So what is f of 2? If this is the function, what is f of 2? Are we there? Let's do it right now, everyone. The function is f of x equals x cubed minus 2x squared plus 5x. What is f of 2? 10. Wow. All right. I had 10 from Prodigy. That's very perfect. Someone else? Anyone else with the answer? All right. I think Mr. Benjamin is getting the same answer. Mr. Benjamin, any answer? Any question? All right. Perfect. Let's hear from, okay, Mr. Wulabi is also choosing 10. Some other people here, please. Let's make sure everyone is moving with us. Okay, I think I have about 1/3 of the class choosing 10. So because of that, I won't waste much time. A function might appear, a particular expression or relationship might appear to be like a function, but might not even be a function at the end of the day. How do we confirm this? There is one test, we call it the vertical line test. Any function that can pass the vertical line test is known as a function. Any expression that cannot pass that test is never a function. That is the logic. We call the test the vertical line test. Vertical line test. Please, everyone, move with me. Write things I'm putting down. Before I take the vertical line test, I wrote it here so I won't forget. There are some things you should understand. The vertical line test moves with graphs. This is a graph. The graph of sine x is like this. If a graph is representing, that is the function sine of x, if y equals sine x, the graph is going to be like this, starting from this place, passing through the origin. Let me do a uniform. So this is how the graph of sine x is going to be. I need it to be uniform. It must pass through this origin. That's it. So graph of sine x. I would like you to put it down. We will be working with them. These are the things that will let you understand these things very easily. So they are not in your materials, but you understand. So ways to understand them easily. That's why the material might not be so straight for some people to understand. This graph is the graph of sine x. The graph of cos x is just a little bit different. That's why you see that the derivative of sine x, when you do the y dx of sine x, is going to give you cos x. It's because they are almost the same. Note that the graph of sine x is starting from, it is going from this quadrant. So now look at the graph of cos x. Graph of y equals cos x, the cos function, cosine function of x. The graph is like this. That is, it is coming from the top like this. This is how the graph of the function cos x comes. Cos x. Just a little bit different from the graph of sine x because it is coming from the top, that one is coming from down. So if it's tan x, this is the graph of tan x. Graph of tan x starts from this place, comes this way. So y equals tan x. I would like you to be putting them down. Y equals tan x here. This graph you're seeing here. These are for trigonometric functions. Y equals tan x. Now, the most important aspect, the graph of x squared. When y equals x squared, I suppose this is even a common question. We'll be encountering stuff like this. So, when it is a graph of y equals x squared, it's going to be like this. It's going to be a parabola facing the top. Parabola. This is it. Y equals sine x, the square function of x. So if it's not this one again, the last one I'm talking about, y equals x cubed, the graph is going to be like this. This is how the graph is going to be. This is how the graph is going to be, passing through the origin here, if it's ordinary x cubed. If it's x cubed minus 3 minus, so it will be shifting. It will be shifting like that. We don't need to be explaining that one in this class. Okay, now, we've gotten the important aspect again. Before I explain it, y equals x squared plus 1. Is there anyone that can answer me? Is y a function of x? That's my question. Is y a function of x when y equals x squared plus 1? Anyone with the answer? I think I know. Okay, I'm still expecting some people that can give the answer.
No.
Is y a function of x?
No.
No. Who's saying no? Mr. Benjamin. Why is that?
Because by the time you find the value of y or the value of x, it's going to give you plus or minus y. I think I
So is that the reason? Is that the reason it is not a function of x?
It's supposed to have a single value.
Sorry. Okay, another person. Thank you. Another person. Is it a function of x or not? Any other person here?
Is a function of x.
Why?
Yes.
Why that?
Because
I'm waiting. Okay. All right. Mr. Benjamin, it's not a function, it is a function of x. So what you said is not correct, sir. I mean, you're right. The reason is this. Y equals x squared plus 1. That means this x squared is a particular image. It's a particular domain in the mapping x. So, and it is entering this place for y. It might be x twice entering y. It's a particular, is a type of mapping. This is a type of mapping. So it is onto mapping. So how is it a function of y? That is what you should ask me. It's quite simple. To determine if y is a function of x, rather, if y is a function of x, then y is going to have one answer. That's it. Y equals x squared plus 1. If x equals to 1, 1 squared plus 1. So y is having 1. But Mr. Benjamin, where you are doing the mistake is that if y is raised to the power of 2, that I have y squared equals x squared plus 1. Please note it very well, sir. If I had y squared equals x squared plus 1, this is where y is not a function of x. Because we will have two values of y. Because taking square root of both sides now, square root of y, square root of this. So square root of this will be plus or minus the value that is inside it. Please, do you get it now? I'm going to explain better, but I'm just answering your own question or explaining the reason I told you that it is not right. Okay? All right. I'm explaining again. I have these three functions. Y squared plus x squared equals 1. 2 is y plus x squared equals 1. 3 is y squared or y plus x equals 1. In which of the following is y a function of x? In which of the following is y a function of x? That is the question. You can write it down. We'll solve it now. We have number 1, y squared plus x squared is equal to 1. 2, y plus x squared equals 1. 3, y plus x equals 1. In which of the following equations, or in which of the equations above, is y a function of x?
2 and 3.
Okay, let's go on. 2 and 3. Definitely you understood me very well. That's great, sir. So let me explain because of those that haven't gotten it well. One is, let's determine if y squared plus x squared equals 1 makes y a function of x. To make y a function of x, or to determine if y was a function of x, you have to make exactly y the subject of the formula here. You make y the subject of the formula. How do we go with that? We say y squared equals 1 minus x squared. That's y squared equals 1 minus x squared. So now, with this, we can say that taking square root of both sides, square root of y squared will be equal to plus or minus square root of 1 minus x squared. So square cancels square root for y, and here I have y equals plus or minus square root of 1 minus x squared. So that means the value of y is either plus square root of 1 minus x squared or minus square root of 1 minus x squared, since I have plus or minus. So the first answer will be plus, the second answer will be minus. Those are two different answers for the value of y. So since y is having two different answers, they might even be the same, and they can never be the same. They can never be the same. So since y is having two different answers, then we say that y is not a function of x. Okay, sure. Since y is having two different answers, then y is not a function of x. You can put since y is having different answers, that is more than one answer. Okay, perfect. Since y is having more than one answer, then y is not a function of x. As simple as that. Let's take the next one. We declare that y squared plus x squared equals 1. Y is not a function of x. We say the next one, y plus x squared equals 1. Is y a function of x or not? What do? We make y the subject first. Now, y equals 1 minus x squared. We've made y the subject. So since it's just one value we will get just one value. That is, if it is 1, it will be 1 minus 1 squared, 0. And 0 is 0. It's not 0 or something. It's not plus or minus 0 we are getting. So exactly, y is equal to 1 minus x squared. So we say y is the function of x. Y is having just one value. So if y is having two values now, or more than two values, or more than one value, then we say y is not a function. But it is having just one value here. We say y is a function of x. Let's look at this again. Y plus x equals 1. We can't make y the subject straight. So y equals 1 minus x. So y is a function of x. Y is also a function of x in this one. And that's how it goes. Again, for those of you that haven't gotten it well, I'm explaining example 1 again. Y squared plus x squared equals 1. Now tell me, is y a function of x or not? Make y the subject. We have y squared equals 1 minus x squared. The next thing is to take square root of both sides. So square root of y squared equals to plus or minus square root of 1 minus x squared. So this. So we have y equals plus or minus square root of 1 minus x squared. So if x is 1, then I'm going to have 1 minus 1 squared. That means square root of 0. That is plus 0 or minus 0. The fact is just that whenever you see that y is having a power, y is having a power that is more than 1, mostly 2, then just know that y is not a function of x equation. Y is not a function of x. That is just the logic there. 2. Know that y is not a function of x. That is it. You have a question? You can mute your mic, sir. You can speak out. The person raising her hand or his hand. Okay, that's that as per that too. I'm looking at what should be next. Let's work with composite function. There are different types of function or mapping. We have the onto mapping, we have the identity mapping, we have constant mapping, we have one-to-one mapping, and we have composite mapping. I'll be working with the composite mapping now. We've done evaluation, right? We said f of x equals 3x squared plus 2. Remember, if it's f of 1, then f of 1 will be what? 3 times 1 squared plus 2. And that's apparently 3 times 1 plus 2, which is 5. That is f of 1. So, composite function is also known as function of a function. That's it's one of the rules in calculus too. We call it a law, chain rule or function of a function. So this is where it actually comes from. That means you are doing a function into a function. Listen very well. A function is this, having 5 as its answer. This one is just a mapping. So, but once it has one answer out, it makes it a function. So we can call it a function too. Don't let me confuse you with that. Just forget you don't know anything about mapping before. Forget that. Let's just concentrate on this. So f of 1 now is giving us 5. What is coming in now is that f of x is this value, 3x squared plus 2. We are now bringing another function. I said composite function is a function of another function. So that means function of a function. F of x equals 3x plus 2. Now, g of x equals x minus 1. F of x equals 3x squared plus 2. And g of x equals x minus 1. Now, we are looking for f, we are asked to look for f of g of x. What are you going to do? What is f of x here? 3x squared plus 2. F of 1 is 3 times, anywhere you see x, put 1 here. Finish. So f of x is this, g of x is this. So f of g of x is this. So anywhere you see x, you put the value of g of x. Let's see. Is there anyone that can do that in here? I will explain that in again before doing it. I said f of x is 3x squared plus 2. So f of 1 should be 3 times 1 squared. That is, I'm evaluating, taking 1 to represent x, because I'm saying f of 1. So 3 times 1 squared plus 2, right? So that's giving me this. So now I'm coming here again and saying f of x equals 3x squared plus 2. And now g of x equals x minus 1. So instead of saying f of 1 here, I'm now saying f of g of x. You know, when I said f of 1, I used 1 to represent x. So when I'm saying f of g of x too, I will use the value of g of x, which is x minus 1, to represent x here. Now let's solve it together, guys.
Say that beg,
Please come again.
I heard one scatter. Come again, Rico.
I'll come again.
Please come again.
Explain calmly. You definitely get it. It's Mr. Charles now. Let me explain calmly. Everyone, just concentrate. I said when it is f of x is given to be 3x squared plus 2. So then, we're saying f of 1. F of 1 will be using 1 to represent x. That's why we are having 1 squared instead of 3x squared. It can now be 3 times 1 squared plus this 2. So now we are now working, you know, this one is just function of a value, function of a number. F of x, we are taking f of 1 now. Here now, we want to work with function of a function, composite functions. So this is a function on its own. This is another function. That's the meaning of function. Huh? So this is composite function. Let's just label it somehow. Composite function. I suppose it won't show there. Composite function. That's what we are working with downward here. So I now said f of 1 is this, right? F of x equals 3x squared plus 2. So therefore, g of x is this. So therefore, f of g of x. F of g of x should be 3 times, wherever I see x, I'm putting g of x inside it. Because when I said f of 1, wherever I saw 1, I saw x, I put 1 here. Now, f of g of x, I should be putting g of x here. What is the value of g of x? X minus 1. No. So, f of g of x, that means f of g of x, that's 3 times, instead of putting x, I'll now say the g of x, which is x minus 1. Listen, I'm solving this. You should quench your test. F of x is this. So g of x is this. F of g of x, you have to write it out that f of g of x is it showing? Is it showing? Is it showing? So f of g of x equals f of, what is g of x? G of x is x minus 1. That is f of x minus 1. We should put it that way. Wow, I think someone did it here. I can't really check the code myself. I'm using something to hold it now. My brothers are not here. Okay. Again, Mr. Chidima or Mrs. Chidima or Miss. Any question? I said f of g of x.
Listen, I thought I got
Okay, sir. All right, sir. Means f of, what is g of x? G of x is x minus 1. So I'm now going to enter it. You know, when it was f of 1, I used 1 to represent x. So now f of x is x of 1, f of x minus 1 will be using x minus 1 to represent x. So I can just say f of g of x equals 3 times, instead of writing x squared, what do I put? X minus 1 plus 2. That, it's as simple as that. X minus 1 squared because of this squared. So just do this, open this bracket. I shouldn't do that for you again. That is x squared minus 2x plus 1. That is to open the bracket. And this plus 2 is outside. Are we together? I will solve another example with something.
No, please. There's no better.
Sir?
I'm confused. I'm totally confused.
All right, no problem. Let me finish.
Sorry, also Said, one other question, please.
Okay.
When you say f of x, what you mean is function of x, am I right?
Yeah, f is a function of x, yes.
Okay, so when you now say f of g, what does that g mean?
That means f of g of x. G of x is another function. That's what I'm explaining since. G of x is a function. F of x is a function. So taking g of x into f of x again, that means f of g of x becomes a function of another function. So we call it composite function, a function of another function. Don't worry, I'll explain it better in this next example. For those of you that have gotten it well, so we will just do this finish and get our final answer as the f of g of x. Again, I'm taking my next example to explain it. Let's just concentrate, guys, please. Jeff of Lagos.
You are Pamu.
Eh?
You would like to.
Eh? I beg, mute your mic.
Said, you know, let us try to.
I said I'm explaining, so don't just go back. F of x equals x squared plus 5x minus 2. This is a function of x. So another function of x is g of x. This f of x might be square of x. It might be square of x plus anything. G of x is another function of x. F doesn't mean that f, because function is starting with f. So f function, no. It's just a type of function. It might as well come as sine x. So sine is the function in that case. It might come as cosine x. Cosine is the function in that case. Here now, I'm taking f of x, where f is the function. I don't know what f is. I just took my own function randomly. So another function is g of x, where g of x is x minus 1. F of x is x squared plus 5x minus 2. So g of x is x minus 1. If you would remember very well, you would know that we mentioned something about evaluation. We said if you had f of x, you can write this down. F of x equals x squared plus 5x minus 2. So what is f of 1? F of 1 is equal to using 1 to represent x. Anywhere you see x, you are using 1 to represent it. That is 1 squared plus 5 times 1, right? Minus 2. Because anywhere I encounter x, I'm using that 1 to represent it because I said f of 1. Note that very well and keep it well. You can write it somewhere in your book. It should be very important for what I'm explaining now.
Please hold on. Yes, please.
You have a question. Okay, I shouldn't rub it. Yeah, I'm waiting for you. So f of x is this. So f of 1 is going to be that x squared. That is 1 squared plus 5 times x, which is 1. You can just look at it. X is representing 1. 1 is representing x here. F of x. That means I'm changing it to f of 1. So in the equation, so f of x 1. F of 1. So that's x squared means 1 squared plus 5 times x is what? 1. 5 times 1 minus 2. So this x is just showing me that, you can see, 1 is representing x. It's a common tactic. It's normal thing. Shall I proceed?
Hold on.
Hold on. Okay. Mr. Elon, agree to sir. Again, f of x equals x squared plus 5x minus 2. So if it was f of 2 that is written here, I'll be using that 2 to represent x anywhere I see x in this equation, in this function. But because it is 1, I'm using to represent x. So anywhere I encounter 1, x, I'll be using 1. That is 1 squared plus 5 times 1 minus 2. That's what is happening here. So now look at g of x. Perfect. Don't forget what happened for 1, for f of 1. Don't forget at all. You should have it in your notebook. You'll be making reference to it now. Now, you have f of x to be the same function, right? X squared plus 5x minus 2. And you have g of x to be another function, x minus 1. We said composite function is having f of g of x or g of f of x. You know, having f of x already, you are now having another f of x inside that f of x. That's f of g of x, f of h of x. That means one function inside another function. We call it composite function. And this is it. F of x equals this now. F of g of x is what we are looking for. F of g of x. What do we go? What do we do? F of g of x, don't forget. Look at it very well. F of, what is g of x? X minus 1. Now come and write it well. F of, instead of writing g of x, just write what? F of x minus 1. As simple as this. F of x minus 1 is equal to, you know, when it was f of 1, we used 1 to represent x anywhere we see x. Because we said x is already 1. It's common thing that when it is now f of x minus 1, then we use x minus 1 to represent x. As simple as that. Let's see, is there anyone that has gotten me here? Is this so hard?
Yes, sir. Sorry, Said. Please, this you know where we are having it, where I am having it with it. I don't know about every other person. Where I'm having it with is this when it becomes a function of a function, that is f of g of x. So I want to ask, if we are looking for this f of g of x, does that mean that we have to first get the function of g of x?
No.
Before we can now find the function of f of g of x.
G of x already. That is it.
Sorry?
When you're talking about composite function, they will give you the two functions.
Okay, so we already know what g of x is.
That is it. It's part of my question.
Okay.
G of x.
Okay, I understand now. Thank you.
Mr. Charles, I will sack you. So that's it. We are given the two functions already. We are not looking for any function by ourselves. F of x is given, g of x is given. Now we are asked to look for f of g of x. You know, we can write it as well in this way. F of g of x. Instead of writing g of x again, I'll just say f of, what is g of x? X minus 1. That is what is here. F of x minus 1. So f of 1 will be representing x by 1, right? Apparently, f of x minus 1 should be representing x by x minus 1. Yeah, let's do that. X squared, that is x minus 1 squared, plus 5 times x. So whenever I see x, I'm using x minus 1 to represent it. Minus 2. Let's finish it and tell me the answer. I think I'll have to do one more example. And after that, if you don't understand, you will have to watch the thing again. The answer, please. 1 squared plus 5 times x minus 1 plus minus 2. Sir?
X squared plus 3x minus 6.
What did you not talk about?
X squared plus 3x minus 6. X squared plus 3x.
What did you say? No talk. Let's hear from other people, please. Well, I think someone wrote it here, but the thing the person wrote is wrong. Let's expand it together. Expanding x minus 1 squared, we are going to have x squared minus 2x plus 1. That is for the expansion of this. Plus expand 5 times x minus 1. That is 5x minus 5. Minus 2 is here, right? Don't forget.
Please come again.
I should come again.
Yes.
Okay. I said we have x minus 1 squared. To expand this one, just write x minus 1 times x minus 1. You want to expand it, right? So that is, use this x to multiply this x. That is x squared.
X squared.
This is x again. Use it to multiply the next value. That is x times minus 1. That is minus 1x. That's minus x. Now use the second value in this bracket to multiply this. Minus 1 times x. That's still minus 1x. That's minus x. Now come and use it to multiply the last thing. Look at my arrow very well. The way my arrow is going. And just write it down. Practice it later. Minus 1 times minus 1 again. Okay, that is plus 1. So I'm having x squared minus x minus x. That is minus 2x. So plus 1 is here. And 5 times x, this is this. 5 times x, that's plus 5x. 5 times minus 1, minus 5, minus 2. So this is x squared is here, right? Minus 2x plus 5x, that's plus 3x. And plus 1 minus 5 minus 2 is minus 6. I think this is what Kodiji mentioned. So this is the function. This is just expansion of brackets. It will only be taking our time. This is just expansion of brackets. Listen again and write it somewhere. You follow the rules later. I said x minus 1 multiplied against x minus 1. It's just expansion of brackets. X times x. You multiply the first value of this one by the first value of this one. That is x squared. Please concentrate. That is x squared. Now you take the first value of this one to multiply the second value in that thing. That is x times minus 1. That is minus x. You now come here, take the second value of this one to multiply the first value of this one. That's minus 1 times x minus x again. You now take the second value of this one to multiply the second value of this one itself. That's minus 1 times minus 1. That is plus 1. And that is why we have x squared minus x, that's minus 2x. Plus this one here. And now, I've just expanded this one. So I'm now continuing that. Plus 5 times x, that is 5x. So 5 times minus 1, that is minus 5. and the minus 2 that is outside before. That's how it goes. That's how it goes. So after doing the arithmetic here, I'm getting x squared plus 3x minus 6. The last example on composite function before taking inverse function. Oh, please, if you are writing it, let's see. Put it down if you would. Okay, I think we should move ahead. I have a function f of x is given to be 3x minus 7. Function f of x is equal to 3x minus 7. Now, another function g of x is equal to x squared minus 1. Okay, let's say it is h of x instead of g of x. Another function. It might be any fucking thing of x. So I'm using h of x now. F of x is 3x minus 7 and h of x is x squared minus 1. Now, we are asked to look for f, that's I, look for f of h of x. Don't be confused, very simple. I, look for h of f of x. Now, we are going to see how interesting it is. Have we written the question down? So we'll be able to proceed. We have f of x equals 3x minus 7 and h of x equals x squared minus 1. So I find f of h of x. Find f of h of x. I find h of x of x. H of f of x. H of f of x. So let's solve it. Quite okay. F of h of x. Write the question out. F of h of x. Now you now write it like a mathematician. What is h of x? X squared minus 1. Don't forget. X squared minus 1. So the f of x is here, right? So I'm now going to write f of h of x is what? X squared minus 1. This is what you are using to work. I said we have f of h of x is what we are asked to look for. We are given h of x. We are given f of x. So what is f of h of x? You are going to write it out very well that f of h of x is what? X squared minus 1. So just write, instead of repeating h of x, you started your work. Instead of writing h of x again, write f of, what is h of x? X squared minus 1. That is what I'm writing. X squared minus 1. So instead of writing f of h of x, I'm writing f of x squared minus 1. So I'll now continue. I'll proceed with f of x squared minus 1. It is equal to, if it was f of 1, anywhere I see x inside the function of f of x, I'll be writing 1. But it is f of x squared minus 1 now. Anywhere I see x, I'll be writing x squared minus 1. Now let's take the function. F of x squared minus 1 is going to be 3 times, this is the function of f of x. So x squared minus 1 minus this 7 that is here already. Please, if you got what I just did now, let me see with your reaction. Please, I will explain again. I don't want to explain this thing the fourth time. 2, 3.
Me, I don't understand it. I don't understand at all.
I understood it. Again, I'm coming again, please. Please listen carefully. I'm trying my best to explain it, and I don't think there's a better way. So I just need you to concentrate more. That is x squared minus 1 minus 7. So let's just solve this. 3 times x squared minus 7. That's 3 times x squared. That's 3x squared. 3 times minus 1. Minus 3. Minus I'm just formulating since. I've explained this thing at the beginning of the semester before. So 3x squared minus 3 minus 7 is minus 10. And this is it. So please, you getting it now? I think some people have gotten it because I've explained it several times now. I'm just tired of explaining it. Please don't have any question. Please. So h of f of x is what we are looking for now. Look at how we are explaining it. We've looked for f of h of x. Now look at h of f of x. H of f of x is going to be h of, what is f of x? 3x minus 7. H of 3x minus 7, because f of x is 3x minus 7. H of minus 7. So don't forget that h of x is here. If it was h of 1 I'm writing, I'll just come and use 1 to represent x squared here. But I'm writing h of 3x minus 7. So h of 3x minus 7 should be equal to, instead of writing x squared, right? 3x minus 7 squared minus 1. So go and solve this one. You're going to have 9x squared minus 6x plus 49 minus 1. That is expanding this bracket. You have 9x squared minus 6x plus 49.
Please, I don't understand. I don't understand this one, please.
Just this bracket.
Please, I did not understand this one. Thank you.
H of 3x minus 7. That means I'm using the function of h of x now because it's not f of, it is h of. So h of 3x minus 7. Whenever I see the value, the function 3x minus 7. Whenever I see 3x minus 7. Whenever I see x, I'll be using 3x minus 7. That is 3x minus 7. And this value is having squared. So squared minus this
Which one are you solving? Which one are you solving, please?
h of f of x.
That's the second one.
I think I'm going to call up composite function, please. I'm tired of explaining it, really. I'm really tired of this. So let me just enter something else. I've explained it so much. You can watch the recording later. I've explained it too much. Too much. It doesn't stress me this way, please. I'm quite tired. I'm really tired. I spent over 30 minutes on explaining composite function. It's not so hard. And this is
Just
even, I
finish the
never
second one. Finish the second one.
it down more than the way I made it. They don't explain it up to this like 3x minus 7. I'm breaking it down for you guys. And why does it seem so? There's no better way, please. I'm really tired. Like this one now is just to expand this bracket. Expand it, write 3x minus 7. 3x minus 7. I treated this last semester when we were doing quadratic equation, factorization. So 3x times 3x, that's 9x squared. So 3x times minus x, minus 21x, minus 7x times 3x. So that's minus 21x again. And minus x times 7 minus x. That's minus 7 times minus 7, that's plus 49. So it's that same thing I explained. That's the way you solve that one. You just expand the brackets.
Can we mute our mics, please?
Coming on, doing my line. So I think we should do something better. I'm tired of composite function now. So okay, inverse of a function. Inverse of a function. That's what we're treating now. Inverse of a function. All these things, I'm trying to explain the basics for you because I hate doing things without understanding the basics. That's why I'm trying to explain it. But even with that, you're not getting the important thing for you to know. So, inverse of a function now, let's just follow the steps. Just don't ask me why is this, why is it this. That just follow the steps. I'm going to tell you the steps and we'll be going with the steps. So you are given a function to be x squared minus 2. Find the inverse of this function. You'll be given that f of x equals x squared minus 2. So what is F inverse of x. F of x equals x squared minus 2. So what is F inverse of x? F of x is x squared minus 2. Find F inverse of x. That's what we are treating now. So inverse means 1 all over, but in function, it doesn't mean 1 over. Don't take it as 1 over. The thing is, that F of x you are seeing, use y to represent it first. That is the first step. Use y to represent it. So write it as y equals x squared minus 2. That is the first step for finding inverse. Have you gotten that? Just change that f of x. Write it using y. Use y equals x squared minus 2. So after getting that, you have to do something. We call it interchanging y and x. Just change y to x and change x to y. You're not bringing anything from one side though. You're not bringing y from this side to this side. And you're not bringing x. No. You just have to change the values. This is y, Abby. Interchange it. And this is x. Interchange x and y. So this becomes x by interchanging. And this becomes y squared. That means you are changing x to y, changing y to x. That is the meaning. Wherever you see x, write y. You see y, write x. That's the meaning. So x equals y squared minus 2. Abi? So here now, after doing that, the first step is to represent f of x with y. After that, you change y to x. Now, make y the subject of the formula. That is x from minus 2 plus 2 equals y squared, right? What do we have? We just take square root of both sides. That means y squared equals square root of x minus 2. So this is plus or minus. Square cancels square root. So we have y equals plus or minus square root of x minus 2. We've gotten it as y, right? So now change it back. Say f inverse of x. Instead of writing y, write it as f inverse of x equals plus or minus square root of x minus 2. Write this down first. Write this down. I'm going to do another example and mention the rules. You just write the rules out, the steps. Write this down first.
Please, we can't see the down.
What did you?
Sorry, should it be x minus 2 or plus?
Okay, Charlie. Please change it to plus. It's plus already. X plus 2. Let's be fast. Okay, one more example. After the example, I'll just mention the steps. Write the steps down. It's not hard. Use it to solve by itself. You call it a day. This is a function f of x equals 2x minus 3. F of x equals 2x minus 3. Find f inverse of x. That's the question. Find f inverse of x. So I just come f inverse of x. That means the first step is to represent this f of x by y. So y equals 2x minus 3. Y equals 2x minus 3. After that, interchange y and x. So you are going to have x equals 2y minus 3. You are interchanging x and y. X is representing y is representing x. So I have x equals 2y minus 3. So now make y the subject. 2y should be equal to x plus 3. That's from bringing minus 3 to the side of x. That's x plus 3. And 2y remains 2y. So to get y now, divide both sides by 2. So y equals x plus 3 over 2. Y equals x plus 3 over 2. Y equals x plus 2. So I've gotten this as y. The last thing is just to what? Change it to f inverse of x. So f inverse of x equals x plus 3 over 2. That's all. So the inverse of this function is x plus 3 over 2. What are the rules we follow? What are the steps? Number 1, we represented f of x using y. Number 2, we interchanged y and x. So here we wrote x, here we wrote y. Instead of y equals to 2x minus 3, we wrote x equals to 2y minus 3. And after that, make y the subject. So make y the subject of the formula. After making y the subject, we just changed y to f inverse of x. And that is the inverse. That is the inverse of the function. Any question? Any question on this? Any question? Mr. Charles?
No.
Okay, so we let.
Yeah, sure.
Okay, I said the representation of is it only y we can represent, or we can represent it?
Yes, it's only y. It's only y. So as not to confuse yourself. It's only y.
Okay.
So I need
Secondly, the inversion. Secondly,
it's only y.
of y and x. Like after the representation, the inversion of changing to y. Is that the second step?
Yes, that's the second step. And the last step, make y the subject, then change y to f of x, f inverse of x. Let me do one last example here. Please write this down if you want.
Please wait 1 minute, 1 minute. How did you see this y? I can put 2s minus 3. But how come
I'll do the next example. You will get it there. Please write this one out. When I'm explaining, you don't let anything jump through you. Listen very well. I mentioned it several times. Can we rub it up?
Yes, you can.
I said, now another f of x is given to the x minus, or x squared, okay, let's use 3x plus 5. Or f of x is given as 1 over 3x plus 5. Let's use a function like this. 1 over 3x plus 5. That's f of x. Find f inverse of x. Find f inverse of x. So let's move on. The first step is to change this f of x, represent it by y. So we have y equals 1 over 3x plus 5. So y equals 1 over 3x plus 5. So change y to x. That means interchanging x and y. Interchange y to x. Y and x, rather. So this y now, write it as x. That is what I'm saying. It's the law, it's a rule in finding the inverse of a function. It is the rule. Interchange there. That's the answer to your question. It's not that I got y from anywhere. I said the first thing is to represent f of x by y. So y equals this function. So the next thing is to interchange y and x inside this function. So wherever I'm saying y now, I'm writing x. 1 over 3. So whenever I'm saying x, I'm writing y. So 3y plus 5. I'm making y the subject of the formula now. So I can cross multiply, right? So cross multiplying, I will have x times 3y plus 5 equals 1. Abi? Are we moving together? Are we moving together? All right.
Yeah. Yes, yes.
Okay, so we can expand this bracket by multiplying x by 3y, x by 5. So this is x by 3y, that's 3xy, plus x by 5, that is 5x. X by 3y, that is 3x times y, that's 3xy, plus x by 5, that is 5x, equals to this 1. Equals 1. Equals 1. So now, let's come up here. 3xy plus 5x equals 1. So we are making this y the subject, don't forget. So we can have 3xy equals 1 minus 5x. Abi? Now we have 3xy. We can divide both sides by 3x straight away. So 3x. This is a normal mathematics. So 3x cancels 3x. We have y to be equal to 1 minus 5x over 3x. I know it might look complex, but it is normal mathematics. It is normal mathematics we are doing here. 3x, y3, all these ones are normal maths. So we've gotten the value of y right here. We got this as y. So after getting it as the value of y, we change it to f inverse of x equals that value. So don't let me confuse you with one. So it comes this way, it ends here. So this is the inverse of the function. Any question first? If I'm going to take on it. Did we all understand it? If you didn't understand it, please show his reaction. I should know if there is a need for another example. Equals 2x minus 7. a function f of x equals 2x minus 7. So what is f inverse of x? F inverse of x. Quite simple. Solution. The first thing is to represent f of x by y. Just know the steps in finding the inverse. Finish. Represent f of x by y. So y equals 2x minus 7. That's the first step. Now interchange x and y, where x equals 2y minus 7. Interchanging. You changed y to x and changed y to x, or x to y. So make y subject. Make y the subject. Make your mind, please. So x plus 7, that's from minus 7 to this side, equals 2y. I can divide both sides by 2 now. So 2y over 2 equals x plus 7 over 2. 2 cancels 2. I have y equals x plus 7 over 2. So now I'm done. I should just change this y to f inverse of x equals x plus 7 over 2. This should be done in 2 lines if you were in the exam or after practicing. So far you practice for the exam, you can do this one in 2 lines. I suppose it's something I can solve without even holding a pen. So what you need is just to practice, please. There are no shortcuts to simple questions like this. So please, are we getting the facts now? So for the composite function,
Yes.
I'm very sure many people understood it, and I'm very sure many people didn't understand it. So, and I was really tired about that composite function. I wouldn't lie to you. I couldn't be explaining like that. I was really tired, so I had to give up. So you can visit the video again, or perhaps you remind me in the next mathematics class. Maybe I can try to, because I'm really tired about that composite function. So maybe we can take it another time. So we really get up to our time today. It's about 10:02 now. It's 2 minutes after 10. So I'm is supposed to end by 10 o'clock. So please take your material and try to work with it. I wish everyone the best. So if you need some other explanations,